Hello everyone and welcome once again to MJ's Maths and Stats. That's MJ Magic Studio to you. I am your host, your host, and as usual in the ghost mode, Mohit Jain. The process, the pattern we have already discussed in our first part. Link is there in the description below. Please go through it. So without wasting any time, let's start now. As promised in previous session, we would be doing a lot of mensuration, and in the beginning we would be starting with revising few formulas for 2-dimensional and 3-dimensional figure. It is a story all about figures, how to find basically area and volume of a closed figure, normally plane figures. So let's start with triangles. 3-sided bounded figure, we know it is a triangle. Basic formula, if we know the base and the height of the triangle, then area of triangle is half into base into height. That's the normal formula. Suppose the triangle is a right angle triangle. Right angle triangle is a triangle where one of the angle is right angle or 90 degree. Then the sides containing 90 degree are called perpendicular and base, and the third side is hypotenuse. Then in case of right angle triangle, area of right angle triangle is again half into P into B. Now suppose on this base H, if we drop a perpendicular which should be the height of this right angle triangle, capital H, then directly they can also ask what is the height of right angle triangle on the hypotenuse, capital H, that is equals to P into B divided by H. And how? We can see that area of right angle triangle is half into P into B, which is also equals to half into base into height. Base is H and height of this triangle is capital H. So on calculating, this is what we get. Height on the hypotenuse for right angle triangle is simply P into B divided by H. Now in case of any other triangle where all the 3 sides of the triangle are known, A, B, C, we can use our Heron formula, which is again very popular formula, where first you find the semi perimeter of the triangle, that is A plus B plus C by 2, and then area of the triangle is given by root over S into S minus A into S minus B into S minus C. Suppose we have a triangle where we know the 2 sides of the triangle. Third side we don't know, but we know the angle contained between these 2 sides. Then also we can find the area of this triangle. Area of this triangle would be half into product of those 2 sides which we know into sine of the angle contained by the 2 sides. So in this case, area would be half into AB into sine theta. Now we will talk about a triangle where all the sides are equal, equilateral triangle. All sides are equal, all angle are 60 degree, all sides are A, and let the height of the triangle be H. Then height of an equilateral triangle is given by root 3 by 2A, and area of equilateral triangle is half into base into height. You can use it, root 3 by 4 into side square. Done. We have one more triangle where 2 sides are equal and it is given, and the third side is supposed to be. It is an isosceles triangle. Clear? The height drop on this base 2B is H, which should be also perpendicular, and it should be bisecting the third side. That is the property for an isosceles triangle. So this will become B and this will become B. So we can see that this triangle ABC becomes a right angle triangle. Therefore H is square plus B square will be equals to A square. In this case, height of an isosceles triangle is given by root over A square minus B square. Now what is B? B is half of the unequal side. that is the height, and hence area of an isosceles triangle will be half into base which is 2b, into height root over a square minus b square, and hence is become the formula that will be b into root over a square minus b square, where b is the semi or half of the third unequal side. Last but not the least, in the triangle, let us take a triangle where coordinates are given to us. So we have a triangle where Cartesian coordinates are given as x1, y1, x2, y2 and x3, y3. So area, as for the formulas goes, is simply half into, why we are putting a mod? Because area is always positive, so we need to take out the positive value. It moves like 1, 2, 3, 2, 3, 1 and 3, 1, 2. This is how formula need to be done. 1, 2, 3 in cyclic order. So it is 1, 2, 3, 2, 3, 1, 3, 1, 2. And how to put in this? This is x1 into y2 minus y3 plus, now start with 2, x2 into y3 minus y1. Now start with 3 plus x3 into y1 minus y2. This is the normal formula we use for coordinate Cartesian systems. 3 points are given and this formula is used. But I would suggest you, whenever these kind of questions are asked, you make any one of the point equals to 0, 0. And hence you see how those get converted. Okay, you can see that suppose x1, y1 we are trying to make it 0, 0. Suppose x1, y1 are 2 and 3. How you can shift it to 0, 0 origin? By subtracting 2 from x and by subtracting 3 from y. This is known as shifting. Clear? So after shifting, if it becomes 0, 0 and this new value become x comma y, capital X2 and y2, and this value become capital X3 and y3. So if you put small x1 and y1 as 0, this will become 0 and this will become 0. This will become 0. So ultimately the area of the triangle will become half into, this becomes already 0, 0 into something is 0. Capital small x2 becomes capital X2 into y3 capital plus x3 into y2 with a minus sign. Clear? So the formula becomes very simple. So you have got this x3, y3 and x2, y2 point. If you can see, we are doing x2, y3. That means inner these two values. We are multiplying these two values. Subtract these outer two values product. And after subtraction, find the mod value and divide it by 2. Simply, suppose the points are 2, 3, 4, 5 and minus 3, 6. And they have asked you to find the area of this triangle. What we'll do, make any of these points 0. So if you are making these points 0, subtract minus 2, minus 3 from all the points so that you are shifting all the points to a new origin. This becomes 0, 0. This becomes 2, 2. 2, 2. And this becomes minus 1, minus 5 and 3. So simply multiply the inside two values, that is minus 10. Subtract the outside two values product, that is 3 and 2, 6. So you are getting minus 16. Mod of minus 16 is 16. Divided by 2, it becomes 8 square units straight away. No need to remember this entire full-on formula. But if in case we are using this full-on formulas, let us see whether we are getting 8 square units or not. Okay, so that would be half into, if I am starting with this, 2 into 5 minus 6 plus 4 into 6 minus 3 minus 3 into 3 minus 5. Let's check. This will be half into, this is minus 2, 3, 4 is 12 and this is minus 2 plus 6. So you can see this is 18 minus 2, 16. 16 by 2 is 8. So instead of remembering this formula, you can use this concept in coordinate Cartesian system and very easily in no time you can find the area of the triangle formed by the three given points on the graph. Moving forward from three-sided bounded figure to four-sided bounded figure, which we call quadrilaterals. Any four-sided figure we have is a quadrilateral. What we need to find is one of the diagonal. If one of the diagonal D is known, and you can see that we can treat them as two triangles. We need the height of this particular triangle and we need the height of this particular triangle. So area of quadrilateral would be half into h1 into d plus half into h2 into d, which will become half into d into h1 plus h2, and this is how formula is derived to find area of the quadrilateral. Suppose we have any quadrilateral where all the four sides are known, A, B, C, D, and a pair of opposite angles are known, theta 1 and this angle theta 2. Suppose this is given, then how to find the area of this particular quadrilateral? First find semi-perimeter, that is A plus B plus C plus D by 2. And find the semi-angle, the two angle which we know. Theta is theta 1 plus theta 2 by 2. Then area of this quadrilateral is given in the same sense as a Heron formula for the triangle. Root over, there is no S, it starts with S minus A into S minus B into S minus C into S minus D minus A into B into C into D into cos square theta. Why we are sharing these kind of formulas? Well, in case this is asked, we can very easily use it. Now we will start with our regular features. Regular features we have got is squares, all sides are equal, diagonals are equal. The diagonal is given by root 2a. Perimeter of an square is 4 times a. Area of a square is a square, which can also be written as d square by 2. If you know the diagonal is root 2 by a, square it up, it becomes 2a square by 2 will give you a square. And we know that diagonal intersect each other at 90 degree and they bisect each other. That is what we mean by intersect each other. Regular staple mein next one is rectangle, where length is not equals to breadth. Generally we take length is greater than breadth. Then diagonal is given by root over L square plus B square. Perimeter is twice L plus B and area is L into B. In this case also diagonals intersect each other at 90 degree. Next is parallelogram. Opposite two sides are equal and parallel. Opposite two sides are equal and opposite two sides are parallel. So you just need to find the height of this parallelogram, that is the distance between the two parallel lines, either distance between B's or either distance between A's. Suppose we have find the distance between these two lines whose length is B, then area of parallelogram is simply B into H. Now we have one more which look like a rhombus. Rhombus is again a four-sided, obviously a quadrilateral. All sides are equal, but angles are not 90 degree. It is different from a square. Clear? All squares are rhombus, but all rhombus are not a square. Here we have got two diagonals, D1 and D2, but here the length of diagonals is not same. And how to find the side with help of diagonal? A square is equals to D1 by 2 whole square plus D2 by 2 whole square, and area of rhombus is given by half into D1 into D2. What we need to remember is this D1 and D2 are the two diagonals of the rhombus. They bisect each other at 90 degree, but they are not equal, and area of rhombus is given by half into D1 into D2. Moving on this, we have next one, which is the shape of a kite, where the adjacent two sides are equal. You can see here, these two sides are equal and these two sides are equal. Again, it is a form of a rhombus. The same concept is used. Diagonals are not equal. D1 is not equals to D2. Formula remains same. Area of kite is also given by half into D1 into D2. Moving on to the last one but not the least is trapezium. What is a trapezium? Where two sides are parallel but not necessarily equal, and the other two non-parallel sides are equal or not equal. We are taking this one as not equal. These two are parallel sides. Let this is x and this is y. Join, form a diagonal. Find these heights h1, h2 and use the same concept. So area of trapezium will be half into diagonal length is d into h1 plus h2. But if we don't have this height, we can use half into x plus y into height. And now where we can use this? If in case we have got an isosceles trapezium. This is x and y, clear, and the distance between these two parallel line is h. These two sides, non-equal sides, non-parallel sides are equal. It is known as isosceles trapezium. In case of isosceles trapezium, we use this formula to find the height of trapezium, area of trapezium, that is half into sum of the two parallel sides into the distance between them, that is height of the trapezium. Okay, moving on to circles. Circle, we have a center and the distance from center to its circumference is known as radius. Double the radius is diameter. So circumference or perimeter, circumference is given by 2 pi r, where pi is equals to 22 by 7. Area is pi r is square, or it can also be written as pi into d by 2. That is, radius is half of diameter is square. So area is pi d square by 4, the simple two formulas. Good. The two different concepts which are regularly asked in circle is, first the ring. We have got two concentric circle and this form a park or a ring, something like that. Inner radius is r1 and outer radius is r2. Then area of the ring is given by pi into r2 square minus r1 square, or simply what we will do, add up the two radius and subtract the two radius, multiply it. Perimeter of the ring, if we can look carefully, it should be outer perimeter plus the inner perimeter. So 2 pi r1 plus 2 pi r2, and hence it will become 2 pi into r1 plus r2. Very popularly asked questions from area of the ring. Next one is our sector. Sector of a circle. And this theta is known. We are looking out for this sector. This is radius, we know, and this portion is suppose length of the sector. So first, length of the sector is 2 pi r into theta by 360 degree, which is equals to L. Area of the sector will be on the same note, pi r square into theta by 360 degree. Now you see carefully, theta by 360 degree, using this particular formula, we can say that theta by 360 degree is L by 2 pi r. So if I am using this theta by 360 degree at L by 2 pi r in the area formula will become pi r square into L by 2 pi r. Pi cancel r. So it will become simply r into L by 2. So in case of a sector, radius and length of the sector is known, but the theta, the angle included in this for this particular sector is not known. we still can find the area of the sector. That will be r into L by 2, and hence circumference of the sector would be r plus L, isn't it? So it will be 2r plus L, very popularly used. Now, to wind up this two-dimensional thing as far as mensuration is concerned, I think these 3 points we should go through, and these are of great use. First is Incircle. We have a triangle, a circle is there which is touching all the 3 sides of the triangle. That circle is known as incircle. And suppose radius of this incircle is r, then small r is calculated as area of the triangle divided by semi-perimeter. This is the formula which we can use straight away. Next is circumcircle. Triangle of side A, B, C, and a circle is passing through all the 3 vertices of this triangle. That is known as circumcircle. And suppose radius of this circumcircle is capital R. Then capital R is given by product of the 3 sides divided by 4 times the area of the triangle. Now in case of equilateral triangle, this is a very common question asked. What is the ratio in case of equilateral triangle? What is the ratio of small r to capital R? We know that in case of equilateral triangle, all the 3 sides are equal. So small r by capital R would be area of the triangle divided by semi-perimeter. So that would be, semi-perimeter is, in case of equilateral triangle, is a plus a divided by 2. That would be 3a by 2. 2 by 3a upon capital R is product of the 3 sides, a into a, that can be a cube, and divided by 4 times the area. So it becomes 2 area by 3a into 4 area by a cube. Okay, so it is a area square. Area of equilateral triangle is root 3 by 4a square. So it becomes 3 by 16 into a to the power 4 by 3 into a cube is a to the power 4. You can see that everything cancel out, and what we are left with is 1 by 2. So in case of equilateral triangle, in radius to circumradius ratio is 1 by 2, that is 1:2. This we can remember. Okay, last but not the least in this, there is the very interesting quadrilateral. We have a circle inside which we have a quadrilateral whose sides are A, B, C, D, and we also have an incircle. Suppose you have a quadrilateral whose 4 sides are A, B, C, D, which can be encircled and circumcircled. Then in that case, area of that quadrilateral is given by simply root over A, B, C, D, product of all the 4 sides. This is a beautiful Brahmagupta's identity which you can use if you have been given a quadrilateral which can be both encircled and circumcircled. Then area of that quadrilateral is product of all the 4 sides, and find the square root of that. Now moving ahead with 3D figures, let's see quickly what are the basic 3D figures which are generally asked. And here obviously the new thing that the volume will also come into the picture. So first we have cuboid, is a form of a box. We have got length, breadth and height. Total surface area will be equals to twice LB plus BH plus HL. Volume would be given by L into B into H. Actually, how do we calculate volume? Volume is area of the base into height of the symmetrical figure. It is a symmetrical figure, then volume is always given by area of the base into height of the symmetrical figure. For any symmetrical or consistent 3-dimensional figure, volume is area of the base into its height. Diagonal would be root over L square plus B square plus H square. Now, if all the three sides are equal, we call it a cube. If L is equals to B is equals to H is equals to A, then it becomes a cube. In that case, total surface area is 6A square, volume is A cube, and diagonal would be A root 3. Okay. If we have a room, we know room have 4 walls and ceiling. So, floor area is L into B, ceiling is also L into B, then area of the 4 walls. Area of the 4 walls would be twice H into L plus B. See, they ask many a times about what is the area of the 4 walls, what is the cost of the painting on the 4 walls. In that case, don't take floor and ceiling, but volume of the room will remain same as L into B into H. Moving next, we will take up right circular cylinder. So that is the radius and height. Curved surface area is perimeter 2 pi r into h. This you should also remember how to generate formula. Curved surface area is perimeter of the base into height. Total surface area is curved surface area and area of the two ends. So that will be 2 pi r h plus 2 pi r square. Volume, area of the base, pi r square into its regular height, that is h. So volume of right circular cylinder would be pi r square h. Now we can have right circular cone. We call it right circular cone, which is 1/3 of the part of the cylinder. We've got height, radius, and this part is known as slant height. So our job is first to find the value of slant height. Slant height is root over h square plus r square. Then curved surface area is pi r L. Total surface area is pi r L plus pi r square. And volume is 1/3 of pi r square. From a cylinder, we can take out 3 equal volume cones. Therefore, volume of right circular cone is 1/3 pi r square h. Next one, we can have a sphere, like a football or a bowl. Radius is r. Then surface area is 4 pi r square, and volume of sphere is given by 4/3 pi r cube. But in case of hemisphere, just remember, curved surface area would be 2 pi r square. Total surface area would be curved surface area 2 pi r square plus this area on the top, that is pi r square. So that becomes 3 pi r square, that's why, and volume would be 2/3 of pi r cube. Last but not the least, we will take up here is bucket or frustrum, which is actually part of a cone. You have a cone. If you cut it somewhere, you will get this lower part is known as frustrum. So we have small r, we have capital R, height h, and slant height is L. First, slant height is given by root over h square plus difference between the two radii. Clear? How these formulas are generated, the full detail, how to construct these formulas, you need to fall back to class 9 and 10, where this has been taught. Or just simply, this is what we are looking out for. If we drop in the perpendicular here, what we can see, this is h, and this portion is capital R minus small r. So if we look at this triangle carefully, this is L, this is h, and this is r minus r, and hence L square equals h square plus r minus r whole square. Therefore, slant height is root over h square plus r minus r whole square. Okay, just remember, try to remember the formula, that would be of more use. Curved surface area of frustrum is pi capital R L plus pi small r L. That's it. total surface area will be curved surface area plus area of the top circle and the bottom circle. So it would be pi RL plus pi small rl plus pi capital R square plus pi small r square. Just try to remember as a concept, very easily you can remember that. And volume is given by pi by 3 into height into, remember this, capital R square plus small r square plus capital R into small r. These formulas would be more than enough to do majority of the questions of mensuration, as in if in case any other particular figure or dimension arrived in any question, we would be trying to bring up with the formula based on the same concept. So let's do few questions now. Question will be displayed on your screen. You know the drill, try it out. Okay, it's a simple thing which we have done in rule number 5 also. If side ratio of any bounded figure is known as A is to B is to C, then area ratio is A square is to B square is to C square, and volume ratio is A cube into B cube is to C cube. That is a duplicate ratio and it is triplicate ratio. Here the perimeter of 3 equilateral triangles are 6:4:1. Since it is an equilateral triangle, if I divide all the 3 sides by 3, I'll get the side ratio. So that means perimeter ratio and the side ratio for these three equilateral triangle are same. Therefore, area ratio would be duplicate ratio. 6 square is to 4 square is to 1 square. That would be 36 is to 16 is to 1. No need to apply formula in these. Option A is the pick. A take on circles. Give it a try. The area enclosed between two concentric circles, that means it is a form of a ring. Area of the ring is given by pi capital R plus small r into capital R minus small r. That is given as 770. The radius of the inner circle, that means small r, is 14. So pi is 22 by 7. 11 2 times 11 70 35. So r plus 14 into r minus 14 is 35 into 7. We can very easily compare and find. If I compare these two, capital R would be 21, and if I compare these two, I'll get capital R again as 35 minus 14 is 21. So capital R is 21. What is the circumference of the outer circle? Circumference of outer circle is 2 pi r. 2 into 22 by 7 into capital R is 21. This goes 3 times. So it is 44 into 3. That is 132 centimeter. Option A is the pick. Area of a rhombus. Area of rhombus is given by half into d1 into d2. That is 162. And length of one of its diagonal equals to side of an equilateral triangle of area this. For equilateral triangle, area is root 3 by 4 into side is square, which is 36 root 3. So A is 6 into 2, 12. One of the diagonal is 12. So D2 will be 162 into 2 divided by 12. 2, 6, 6, 2, 7. So length of the second diagonal is 27. Length of first diagonal is 12. What is the difference between the diagonals of the rhombus? D1 minus D2. They are looking out. That is 12 minus 27. 15 centimeter. Difference between two diagonals is 15 centimeter. Option A is the pick. Find the area of an isosceles triangle. A. Let this side be B. 2B. With one angle 120 degree and side opposite to the largest angle is 10 root 3. This is 10 root 3 and this is 120 degree. So 180 minus 120 is 60 degree. So this is 30 degree and this is 30 degree. If we drop a perpendicular, this is 90, this is 30 and this will be 60. Okay, and this is half of the base, this is 5 root 3. So let me design it out here. It is 5 root 3. This is 30 degree. This is A and this is height. This is 90 degree. Okay. Perpendicular by base is 10 theta. 10 theta will be h by 5 root 3. Theta is 30 degree. 10 30 degree is 1 by root 3. That means height of this triangle is 5 units. Find the area. Area is half into base. Sorry, this is height into base. So area is 25 root 3 square centimeter. Option A is the pick. Use of a bit of trigonometry also to solve this question in no time. Classical take on your screen. Give it a try. You know the drill. Okay, let's see what we have. A large rectangular park, 500 meter long and 300 meter broad, has two 2 meter broad walkways, one parallel and one perpendicular to the length. One parallel and one perpendicular anywhere. What is the area of this parallel walkway? It is 500 into 2, that is 1000 meter square, and area of this perpendicular one is 300 into 2, that is 600 meter square. And we can see that this particular segment is accounted for twice. This is 2 by 2. 2 by 2 is 4. So the area of the walkway is 1000 plus 600 minus 4. That is 1596 meter square. Now what is the question? If this walkway is to be paved with tiles half into half meter, how many tiles would you require? Area of one tile is half into half, that is 1 by 4 meter square. The number of tiles required, area of walkway divided by area of one tile, that is 1596 into 4. Okay, 60, 24, 2, 38, 63, 6384. 6384 square tiles are required, that is in option A. This is what we need to focus on, this double area which we have accounted for in these type of question, which need to be deducted. Let's move on. A take on triangles and circle. Give it a try. The area of a triangular park whose sides are these is equal to area of circular park. Okay. Find the length of the diameter of the circular park. Take pi equals to 22 by 7. For area of a triangular park, we can use Heron formula. First, we need to find the value of S, 72, 154, 170. This is 6, 14, 19, 1, 396 by 2 is 198. So, area of triangular park is root over S into S minus A, 198 minus 72, 126 into 198 minus 154 is 44. 198 minus 170 is 28. Okay, we can use on-screen calculator if it is required. So we have 198 into 126 into 44 into 28, and that square root will give 5544. So area of circle will be also 5544, which is pi r square or pi d by 2 whole square. Simple, as we are looking out for diameter. So 5544 into 4 by into pi is 22 by 7. into 7 by 22 equals to d square. Great. So 5544 into 4 into 7 divided by 22, and when we square root it, it's give us 84. D is equals to 84. Diameter is 84. That is in option A. Use on-screen calculator if it is available. One more take on circle. Let's try. What we understand by this thing, that area is 300% more. If something is 300% more than some other thing, that means the other thing is how many times of the previous one? 300% more means it is 1 plus 3, 4 times the previous one. Mind this and find the answer in no time. Let's now find out what is the answer. The diameter of a circle A is A plus B units. Find the radius of the semicircle whose area is 300% more than that of the circle A. Area of circle A is pi into d by 2 whole square. Now area of semicircle is given by pi r square by 2, because it is half of the circle. Its area is 300% more than area of circle A. That means this area pi r square by 2 is 4 times the area of circle A. 300% more. 300% more means 1 plus 300 by 100. That is 4 times. So if we solve this, what we'll get? A plus B whole square by 4 into 4 equals to R square by 2. What is the radius? They are looking out for value of R. So it is 2 into A plus B whole square is R square. Therefore R is root 2 into A plus B. That is root 2A plus root 2B. That is in option A. (15 to 20 seconder on your screen, reading time, and put the tick. Do it. The lengths of parallel sides of a trapezium is x and y, and the area of trapezium is this. What is the distance between the parallel side? Let the distance between the parallel sides d, then area of trapezium is given by half into d into sum of parallel sides. That is equals to half into x square minus y square. That means x plus y into x minus y. Just equate and we'll get the distance between the two parallel sides is nothing but x minus y. Mark on option A and move on. So, show me your interest in 3D now. Okay, the classical take on 3D. A solid glass cube of side 2 meter is placed inside a globe, spherical globe, such that each corner of the cube touches the surface of the globe. That means diameter of the sphere is actually diagonal of cube. Diagonal of cube is given by root 3 side, root 3 into 2. That will be 2 root 3. So diameter is radius, double radius. So radius of the sphere is root 3. Now what is the volume of sphere? Volume of sphere is 4 by 3 pi r cube. That will be 4 by 3 pi into 3 root 3. That will be 4 root 3 pi. And volume of cube is side cube, a cube. That is 2 cube, that is 8. So we have this sphere. Inside that we have this cube. Correct? So what is the volume of the region inside the globe but outside the cube? We just need to subtract these two. 4 root 3 pi minus 8, or if I take common 4, it is root 3 pi minus 2. That is in option B. Let's move on. One more on 3-dimensional. Let's see. If the area of the curved surface of a cone, whenever a cone is given, we treat it as a right circular cone, unless and until something else is given. Radius, height and slant height. Curved surface area is pi RL, is 2 times the area of its plane surface. Okay, plane surface area is the area of the base, that is pi r square. So curved surface area pi RL is 2 times the area of plane surface, pi r square. Pi cancel, r gone. That means L is equals to 2r. Okay, what is the angle between the axis and the generator of the cone? We are looking out for this angle theta. This is the right angle triangle. If we see, this is the right angle triangle. This angle we are looking out for is theta. This is L. L is equals to 2r. And this is r. So we have perpendicular by hypotenuse. Some people have sine theta. Sine theta is perpendicular by hypotenuse. That is equals to half, which is equals to sine 30 degree. Sine 30 degree is half. Therefore theta, or the angle between the axis and the generator of cone, is 30 degree. That is in option B. Kaleidoscope. Try it. Three plane mirrors of size 10 cm and to 3 cm are used to construct a kaleidoscope, that is a type of a prism, attaching each pair of mirror along their lengths. So these are the three. We get something like this. What is the total volume occupied? Volume of any prism is given by area of the base into its regular height. Suppose this height is 10, and if we see carefully, base is nothing but an equilateral triangle with side 3 cm. Area of equilateral triangle is given by root 3 by 4 side is square. So that would be 9 root 3 by 4. And hence the volume of the entire figure, entire prism, what we get is area of the base into height, that is 10. So 2, 5, what we get here is 45 root 3 by 2 centimeter cube. 45 root 3 by 2 centimeter cube is in option A. Area of any prism is given by, volume of any prism is given by area of the base into the height, and it should be a right height. Right height means uniform height. Yes, you know the drill. Give this a try. A metallic solid cube of side length 4 cm is melted. Whenever it is the concept of melted, we need to find the volume of the first body. Volume of cube is 4 cube, that is 64 centimeter cube, and made into a hollow sphere of internal radius 3 cm. Hollow sphere volume is given by 4 by 3 pi r cube minus small r cube. Internal radius 3 is given, that is small r value is given 3. External radius capital R value is what they are looking out for. So 64, that is 4 cube if we do. That means 4 cube is 64. 64 equals 4 by 3 pi into capital R cube minus this small r is 3, that is 27. So this is 16. 16 into 3 is 48. 48 by pi, if I take this 27 here, plus 27 will be equals to capital R cube. So R is 48 by pi plus 27 whole raised to the power 1 by 3. 48 by pi plus 27 raised to the power 1 by 3. That is in option B. Do practice. There is one file of more than 100 questions are solved. Link will be there in the description. Go through it once if it is required. Subscribe to the channel if you haven't done so. Question is on your screen, do it. The height and radius of a cone is 15 meter. We have height and radius. So 225 and 64, 289, 17 square. Slant height is 17. Let's move on. If the cost of painting is rupees 14 per 1 square meter, find the total cost of painting curved surface area. Curved surface area is pi r L. Pi r and L. L we have already calculated, 17. And the cost of painting rupees 14 per square meter. So this is square meter into 14. That's it. Into 2. So it is 22 into 16 into 17. 274. Only this is the option which ends with 4. Option A is the pick. Let's check. It is 22 into 16 into 17 is 5984 rupees. Option A is the pick. Do look out for the link in the description for more videos. I'll see you soon.